they're joining. I don't know what happened yesterday. They were trying to. No, you'll have to do stuff. You're not gonna do nothing. Huh? Yeah, I'm gonna let y'all can do the first example with me. And then I'm just mainly gonna teach the online kids because they didn't get it yesterday. And then y'all can just practice on your own. Right? So we all do the first one with me. I started a little bit. Okay, hey, first period. So yesterday, I don't know really what happened. I used the same link today and I did the same thing and now it's working. So I really don't know what happened yesterday. So I'm just gonna give you the lesson that we were supposed to do yesterday. And then you'll just do, we'll just basically do yesterday's lesson and then we'll go from there, okay? All right, so let's see, let's also go over yesterday's warm-up. So let me open up a few things and just to get ready for today. I walked in kind of late today. So the point of yesterday was a lesson that even if you looked at the notes, would be a little bit hard to understand without me being there. So if you didn't understand it, that's okay. I wouldn't expect you to because it was kind of difficult. All right, add in a new slide. But if you are joining in, this is kind of like a note intensive lesson. So I would take notes. If you have graph paper, then I would use graph paper. But if you don't have graph paper, then regular paper is fine. Or if you have a journal, and then when we do these two examples, I would 2 or 3. When you do these examples, I would keep these as notes because they help when I assess you, right? If I give you an assessment and then you have to actually do it, it helps in having an example with you. So I would take notes and then I would also keep them for future reference. Okay, so let's go to Schoology. And let's look at the warm-up from yesterday. I saw a few of you had done it. Let's see if any more. And I didn't add anything new for today since we're just kind of catching up. All right, so here's the warm-up. So for the warm-up, Bill is casually walking back home from his friend's house when he discovers he's left his wallet at his friend's house. He turns around and sprints towards his friend's house. So one thing you have to ask and remember is home is always the reference point. And so is he starting at the reference point? Is he starting at his home or is he walking towards his home in the backwards direction? Because that's where I saw most of the mistakes on these motion maps, right? So yeah. So remember, there's more than one motion. So right, this has at least a change in direction. However, he should be first walking back, like walking towards home and then sprinting back. But it has the change in directions. And then the second motion is faster because he's sprinting. So that's good. The only thing is they're flopped. They should be, I'll show you here in just a second. Yeah, same thing. Okay. So this is what this should look like. So remember when we do motion maps, the first thing that we're going to do is we're going to draw an X, and that's the reference point, right? It's position 0 meters, and this is the positive direction. And one thing that we have to remember is that this side of the motion map exists too. It's just the negative position side, and we'll get there in just a little bit where we're actually going to use that side. Okay, so he's walking home. Home is the reference point, so he's walking to home from his friend's house, right? Then he's like, oh no, I forgot my wallet. And so he sprints back. And so his arrows, are they going to be shorter or longer? Longer, right? Okay, I'm going to turn on my chat too for the, they're going to be longer. And then he sprints back because he forgot his wallet. Now, I wouldn't have put that he stopped, but if you're like, oh, he stopped and then turned around because he realized he forgot, that's fine. Okay, so they should all be the same size, just longer. I realize that second one's a bit longer than the other ones. But that's how you would draw this motion map, okay? And so we're gonna kind of practice that today, and then we're gonna add in other representations that you're gonna be expected to be able to do, okay? All right, so like I said, take these notes, and y'all take these notes, because did I give you all the units and all their variables yesterday? My face-to-face? Did I? Like, did we list like distance, speed, velocity, position with the unit? Can't remember. All right, so take these notes. They can't remember. To be honest, I don't really remember either. Okay, so before we get started, I would take these notes and then keep them, because I'm going to start using these abbreviations. All right, so make this chart with me. Make this chart with me, unless you made it yesterday, which I don't remember making it with you. All right, so variables. And then there's the symbol. And then there's the unit. And then there's the, maybe it has a formula. Okay. All right, so the first thing that we learned about in this class so far was time. Let's do time. Time. Time is the letter T, and it's in seconds usually, and we don't really have a formula for it. And then we learned position. The symbol is X, and it's usually measured in centimeters or meters or kilometers. And there's not really a formula. And then we learn distance. The symbol is the letter D, lowercase, same unit. Okay. And then we learn displacement. Now, displacement is how far you are from where you started. or technically just a change in position. How did your position change? So in math, you might have learned that this symbol means change. This delta. Change in position is displacement. Okay. Now, there is a formula for displacement, and it's going to be, I may have shown it to you, but I don't know, but today I will. Displacement equals the final position minus initial position. So final minus initial. Speed centimeters per second, meters per second, miles per hour, anything like that. And then we kind of figured out that speed is the distance divided by time. That's not a very good D. And then velocity. Okay. All right. So it's the same thing as speed, but plus a direction, not plus. And a direction. Okay. All right. So those are the variables so far, and their symbols. I'm going to be using them just a little bit more, so I don't have to write them out every single time. But that'll kind of help you. And then we'll kind of add on. If you just like keep that chart, we'll keep adding on to it. Okay? Because there's a whole bunch of symbols and variables in this class. Is everyone online good? Oh, it's just distance over time with the direction. Cool. Okay, so let's go ahead and get started, and let's do a specific example. So let's start with another motion map. Okay. All right. So this, it's going to be a little bit more quantitative, which means I'm putting numbers with it now. So I want you to do this on your piece of paper. This is part of the notes. So please do this on your own piece of paper. All right. And then y'all do this too. So a bowling ball starts from the edge of the lane, rolls at a constant 2 meters per second for 6 seconds to the pin. So I told you that the edge is the reference point. So are the arrows for your motion map going to point to the right or point to the left? Yeah. What do y'all think at home for this one? Is your arrows going to point to the right or to the left? You can do it. To the right. Good. Yeah, because this is just a straightforward, it's starting from the reference point, right? It's starting from right here. So sketch it out. Sketch it out on your paper. Take like 45 seconds, sketch it out. like my shoes? You didn't finish it. No, sketch the rest of it though. That's just the basics. That's just, you draw that every single time. All right, so your motion map should just be straightforward. Starts from the reference point, goes forward at a constant speed, same size, pointing to the right. That's all I'm looking for, okay? All right, so let's take it a step further. Let's introduce the data table. All right, the data table is basically a T-chart. It has time on one side, position on the other. So make sure you're including this in your notes, right? Okay, so time, that might always have a label and a unit, always label in a unit, and then position, and then a unit, meters. And so we're going to, on this data table, map out where the bowling ball is every second of its motion. So if the bowling ball starts at the edge, at the reference point, at 0 seconds, what position is it at? 0. It's going to be at 0. And then every second after that, it moves 2 meters a second. So where is it going to be after 1 second? So at home, y'all can just finish it on the paper since y'all got it. But at home, since it's moving 2 meters every second, where is it going to be after that first second? Two. And then at 2 seconds, where is it going to be? Yeah. All right. You got it. And then 6, and then 8, and then 10, and then 12. You got it. Okay. So now I have my data table, and I can tell where it was at every second. What total distance did this bowling ball cover? What's the distance here? Huh? What about y'all at home? What's the total distance? That this bowling ball covered? Y'all can go ahead and start graphing it. All right. We'll get back to those. All right. So now that we have this chart that looks like this, right? It's time, and then position, and meters, and seconds. Right? So now I have the perfect setup, right? I have basically an X and a Y column. And so what we do is now we graph it, okay? And whenever we're graphing our data, we always use the first and the fourth quadrant, okay? What do I mean? I mean, we use this and this quadrant. Position is always on the y-axis. Position is always on the y-axis. Time is always on the x-axis. Time is always on the x-axis. And we're never going to use this side of the graph right here because there's no such thing as negative time. Okay? No such thing as a negative time. in this, what's that word? Yeah, in this dimension. All right, so then we label, right? We got to get to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we have to label time. You gotta get to 6. 1, 2, 3, 4, 5, 6. And then you plot. My allergies, I can feel it. All right, 0, 0. 1, 2. 2, 4. 3, at 3 seconds, they were at a position of 6 meters. At 4 seconds, they were at a position of 8 meters. At 5 seconds, they were at a position of 10 meters. At 6 seconds, they were at a position of 12 meters. And then you do your line of best fit. Okay. For my online people, is that a positive slope or a negative slope? Yeah. Perfect. Yeah. And we already knew that was going to be, we already could kind of tell it's positive because the object's moving in the positive direction. It's moving to the right, right? So it's moving to the right. So that gives it a positive slope. So can you tell me now what total distance it covers? What was the total distance of this object? $12. Yeah. What about displacement? How far is it from where it started? Mm-hmm. 12. But in what direction? To the right. Okay. All right. Let's do another one. Look at this one. Let's answer these questions first before we start it. So also, you'll start with different things. So this is a new one. Look at the data. Is this object moving forwards or backwards? I'm waiting on online answers. Is this object moving forward or backwards? What do you all say? How do you know? Yeah. You know it's moving backwards because its position is decreasing, okay? Now, what happens right here? It's at the reference point at 0, and then what does it do? Passes the reference point. So by just looking at this data, so let's write that, passes the reference point. What total distance did this object cover? Close. So what total distance did this cover? You did? I didn't hear that. Okay, so sometimes this is hard to see by just looking at the numbers. So let's go ahead and draw the motion map of this, and then you can kind of see it. It helps visualize it a little better, and that's the point of the multiple representations, that you can see the motion in different ways, okay? So since we said it's going backwards, are the arrows going to point to the right or to the left? Yeah, good, perfect. Okay, to the left. Okay. All right, so now let's sketch the motion map for this. Sketch it real fast. Sketch it in your notebook. You all sketch it on your paper. And then remember, it passes the reference point. I'm so hungry. Oh, almonds. That's funny, Jordan. Hungry. Is that the new one? Doesn't turn around. Remember, it doesn't turn around. It just passes the reference point. Remember, arrows are pointing to the left. Yeah. Why is your reference point? Look, this is a line that establishes positive direction. So you've established positive direction to the left now. So your object moving forward, not backwards.
What does that even mean?
Remember, this line right here establishes the positive direction. And remember, I had mentioned that this line is just position, right? This reference point is 0 meters. That means that 30 meters is somewhere over here, right? And the way I usually make my kids do these motion maps is I make them actually number the line. So this would be 6, 12, 18, 24, 30. Oh, they're not evenly spaced. And so that means -6 is over here. And so basically each second it just covers 6 meters backwards to the left. Okay. So I'm not looking for numbers on your motion map. I'm just looking for a trend. I'm looking for arrows that are the same size that point to the left, and for this one that pass the reference point. Okay. And so now that you're looking at it, what total distance did this object cover? What's the distance? Ask yourself, how much does he cover when he's going from 30 to 0? How much does he cover right here? What does he cover from 0 to -6? So how much total distance does he cover? Okay. All right. What about displacement? Is it going to be a positive displacement or a negative displacement? It's going to be negative. And so remember, I had a formula, and my formula was the final position, final minus initial. What's my final position? What's my initial position? What's -6 minus 30? -36. Yeah. So if you use that on number lines or graphs, you'll always get the correct answer. Sign included. So there you have the displacement with the sign. Remember, distance never, ever, 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 ever has a sign. All right. And then you graph it. Sketch this. So for this one, you're going to use both quadrants. Right? I'm going to go ahead and count by sixes to make my life a little bit easier. 6, 12, 18, 24, 30. -6, -12. I don't need all the way down. 6, 12, 18, 24, 30. Labels, unit, labels, unit. And then you plot. Let's make this a Christmas one. At 0 seconds, it started at a position of 30. Oh, I forgot to do my time. 1, 2, 3, 4, 5, 6. Okay. Christmas. At 1 second, it was at 24. 2 seconds, it was at 18. 3 seconds, it was at 12. 4 seconds, it was at 6. 5, 0. 6 seconds, it was at -6. Okay. This is basically what we did yesterday, but nobody could log on. All right. So what I'm going to do for you today is put in the check for understanding or the daily engagement that I wanted you to do yesterday, but you might not have understood it. I'm going to copy it so that you can do it today for practice. Okay. Does anyone need me to keep the screen up? Can I move it, or do you need it to stay there a little longer on mine? Are you good to go? One sec. Okay. Where's my phone? Tell me when you're ready, Jordan. Okay, perfect. All right, so I'm not gonna lie, I didn't create a folder for today. So let me do that now. Let's do pink. Okay. This is the one that I wanted you to do yesterday. Okay, so now you should be able to go and do the, well, let me publish it. So now you will see it. But before you get started on that, the one that is for today, I give you a motion map first. So I started with the description, and then I started with a data table, and now I'm giving you the motion map. So the first thing you're gonna have to do is to create the data table from the motion map. So let's look at this one. Each arrow was 1 second, okay? If each arrow is 1 second, how many meters a second does this arrow cover? Yeah, it's covering 3 meters every second. And so when you create your data table and you draw on this one, for example, at time of 0, at 0 seconds, where does this object start at? So online, where does this object start at? Yeah, 0. And after 1 second, where is it at if each arrow is a second? Yep. And after 2 seconds, oh, that was a bad line there. Perfect. And then, yeah, so that's what you're doing on today, is then you're creating the graph and all of that, okay? And the motion map was given to you. So when you do this online, it's a different one, but when you click on it, I can preview. Oh, you only have 1 attempt. I can give you 2 attempts. But here it is, and then you graph it, and then it asks you a couple questions, I believe. Oh no, it doesn't. I don't want that one. I got a better one. I'm deleting this. Okay, now this is the one that I liked better, I think. Now you can go in. Yeah, that has 3 questions. Perfect. So now you'll do this one. It's the same thing, just I added a couple. All right, so go ahead and get started on that. Let's see. All right, so that's what you'll do for the remainder of the period. Just work on that. And you'll have to kind of draw on it like you did that one warm up. And then that's it for today. I'll go ahead and post in today's folder the my notes that have the written notes too, my teacher notes. They're in downloads. 2020. Yeah, the teacher. Okay. That's it, guys. Do y'all want to do the online one? Y'all doing the online one? Y'all do the online one. Or do you want to do it on paper? Oh, well, you can do it later. Give you a 10-minute break. Not y'all online. Y'all got like a 50-minute break yesterday. I'm stopping the share. Does anyone online have any questions? Y'all stay there, don't leave. I want to take roll from the Zoom. Who is C. Mitch? Who are you, C. Mitch? What's your real name? I don't know who to count as you. I know.
It's me,
Who's me?
Sit Lolly.
Oh, okay. Thank you. Oh, awesome. Perfect. Okay. What am I going to do in the rest of my classes today? think this class ends at 8:11, so like right now. Oh, 8:12. I'll go ahead and end the Zoom. Just make sure you get that done, and then I'll see y'all tomorrow morning. Y'all have a really good rest of the day, okay?